Okay, let's talk about implicit differentiation. So, implicit differentiation isn't really different than what you've done before. It's just that when we can't isolate y on one side of the equation, so we can't get y equals mx plus b or y equals x squared plus 3x minus 5, then we have to differentiate in line, which just means term by term by term, and that's implicit differentiation. So in this case, we start out with x squared. So I'm going to write that a little bit bigger so you can see, but it's x squared minus 3xy plus y squared equals 1. Now, here's the deal. Variables are functions. So when we're differentiating the function, this x times y is going to have to use product rule because it's a function times a function. Function x times function y. Because it's a variable, we really don't know what it holds. Could be a number, which is the constant function. Could be a line, could be quadratic, could be anything. So we treat variables as functions as we go in line. So if I take the derivative of x, I would represent that as x prime, or dx dx. If I take the derivative of y, I would represent that as y prime, the derivative of that function. But because they're asking me to find the value of dy over dx, when I take the derivative of x, I would just get dx over dx, which is 1, so it cancels. Okay. If we were taking the derivative with respect to t, then we would get 2x x prime, 2y y prime. Anything that's not the variable that we are focusing on, which is found in the denominator of this differential quotient, would get a prime notation representative of its derivative. But in this case, the only thing we're going to have to worry about that for is the y's, because they are not the variable we are focused on. We are focused on the x, the focus of our differentiation. Okay. And then I'm going to go just term by term differentiating these. So that first term, x squared, the derivative of x squared with respect to x would be 2x, just power rule. Okay. Then we get to this 3 times x times y. Okay. I'm going to separate that a little bit. So the minus 3, I'm going to factor out, and then I'm going to do product rule to get the derivative of the x and the y, which, since they're just x and y, is literally writing the product rule, that 1d2 plus 2d1. So it's 1d2 x and the derivative of y, which is dy over dx, or y prime, plus 2d1, which is y times the derivative of x, which is dx over dx, which is just 1, which is why we don't see it as x prime. And then we move on to our last term here, which is y squared, or last term on the left-hand side, I should say. Y squared, its derivative would be 2y, and then dy dx, which would just be y prime, is equal to the derivative of 1. The derivative of a constant is 0. Now, at this point, we have differentiated the function. But it's kind of a mess. Not really very useful. So we want to simplify, and since the original problem is asking me to find the value of dy over dx, I want to see if I can solve for that y prime, which is equal to dy dx. Let me write that somewhere. The derivative of y over the derivative of x. That prime notation that we've been using is really just a simpler way to write that so that we don't have dy over dx in our equation when it's unnecessary. We're not talking about differential equations yet. That's in just a little bit. But I want to try to solve for y prime. So from here, it's really just algebra. Moving terms around in the expression to isolate y prime, and then we're going to plug in the point 1, 0, which x equals 1, y equals 0, to see if we can get an actual value for that slope or rate of change for the variable y with respect to x. So isolating y prime, doing the algebra, minus 3xy prime minus 3y plus 2y y prime equals 0. Going back all the way to algebra 1, where we remember that if we want to solve for a specific variable, all we have to do is make sure that that variable is collected on one side and everything else is on the other side, and then just combine like terms and divide out. So that's what we're going to do. I need the minus 3xy prime and the 2y y prime to stay. So I'm going to add the 3y and subtract the 2x on both sides. So we're going to get the plus 3y minus 2x over there. So that now my equation is negative 3xy prime plus 2y y prime is equal to 3y minus 2x. And you may recall, this is a method called creating a common factor or forcing a common factor. That's why we collect all the terms with the variable that we are looking to solve for on one side of the equation, because it forces that side of the equation to have that common factor. In this case, y prime. So I want to factor that out. Y prime, which then is negative 3x plus 2y is equal to 3y minus 2x. And then I can just divide. So that's what I'm going to do. I'm going to divide out this, 2y minus 3x. And the same thing over here. Okay. That's y prime. Y prime is equal to 3y minus 2x divided by 2y minus 3x. And now, if I want to find the value of that derivative at 1, 0, I just plug that in. Notice it's an ordered pair, so that's x, that's y. So x is 1, y is 0. If y is 0, that's just negative 2 times 1 over negative 3 times 1. Negative divided by negative is a positive 2/3. And then this is the same. There you just go down the line. You're going to use product rule there. I don't know if it's negative 1 or not. I just want to get to the other ones. Well, guessing, not a great way to answer questions. Or randomly guessing. Yeah, look at that, we got it. Yep. There we go. That one just wants the derivative, which is the step before plugging in the value. I think we covered it all, but I want to make sure there's not a surprise one in here. Yeah, you got that one on the second guess. And then, yeah, same idea. A little bit of product rule in there, but just implicit. So follow that first example. I'll go ahead and do this one real quick so you have another example. But we have x plus 2xy minus y squared is equal to 2. So again, power rule, product rule, power rule, constant. But make sure you look to see what rules are you going to have to use for implicit differentiation, which will either be power rule, product rule, or very rarely quotient rule. But for the most part, you're going to be looking at power rule and product rule for these. But taking the derivative, as we move down, the derivative of x is 1 dy dx plus 2. We're going to break that up. Product rule, so 1 d2 xy prime plus 2 d1, which is just y, minus this 2y y prime is equal to 0. Notice, for the variables that are not in the denominator of my derivative expression, dy over dx, I add y prime to indicate that derivative. But for x, the derivative of x with respect to x is dx over dx, which is 1. So we don't have to worry about it. But normally it would also be there. Now, solving for y prime, in this case we'd have 1 plus 2xy prime plus 2y minus 2y y prime equals 0. Getting the terms that I want with the y prime on one side, moving the terms I don't need onto the other side, we would have 2x y prime minus 2y y prime is equal to negative 1 minus 2y, subtracting these two over. And then we're just going to divide out. So we have y prime is equal to our negative 1 minus 2y over 2x minus 2y. Which we could do some simplification here too, but that's enough. We're going to plug in this 0.24. So we don't really need to do any simplification. But I feel like I want to. So I'm going to negative here and make that 1 plus 2y. And I'm going to factor out 2 here and make that just x minus y. Then I'm going to factor a negative out here and switch the order so that that becomes x and that becomes y. And then I can cancel that negative, which really doesn't do much for us here. But later on, when the math gets way more complex, sometimes that little bit of simplification, canceling a negative or looking to see if there's a way to rearrange, can be the difference from a very, very complex operation to something relatively simple. So in this case, it doesn't really make much of a difference. It was just for fun. But now that's our derivative. Y prime is equal to 2y plus 1, or 1 plus 2y over 2 times y minus x. And then our point is 2, 4. So our x is 2, our y is 4. So if I were to plug that in now, y prime at the point 2, 4 would be 1 plus 8. So we'd have 9. So y prime at the point 2, 4 would be 9 over, and then on the bottom, y minus x. 4 minus 2 is 2, times 2 is 4, so we have 9 fourths would be our answer there. I'm not going to check it because it'll mess up my average on Khan Academy though, but you can assume it's correct. Yeah. All right, guys, that's implicit. We'll look at second derivatives and just moving on. Like I said, if you're done with that stuff on Khan Academy, keep an eye out for the tests. I'll get those posted this week. Just derivatives, and then we'll look at the integrals a little bit. And then differential equations, all relatively simple stuff, mostly review. And then you're done. So, keep working. Stay safe. We'll see you next time.